Hi guys, today we're going to be doing a problem on page 222, number 36. This is another Hess law problem for Thermochem. It's somewhat similar to the Hess law problem we did before, but there are a couple more steps that complicate the process a little bit. But I'm just going to talk through it and help you guys out. And once I talk through it, hopefully it'll make more sense. So the problem says, given the following thermochemical reactions, calculate the heat of formation for the formation of dinitrogen pentoxide from its elements in their stable state at 25 degrees Celsius and 1 atm. So like the other Hess law problem, we're given three different equations or different steps for this that take place for this fourth general reaction to occur. We have the reaction of hydrogen and oxygen to produce water. We have dinitrogen pentoxide and water that yields nitric acid. And then we have this third equation where we have nitrogen, oxygen, hydrogen added together, which yield nitric acid. Now each of these three reactions we're given the delta H values as well. And now we'll start going through and we'll simplify these three equations to get our fourth and final equation at the end. So speaking of this fourth and final equation, we're asked to find, we need to find the equation that illustrates the given reaction, which is the formation of dinitrogen pentoxide from its elements. So if you remember the strategy we used in the last one, we just need to find, if you think about, you don't have to write it out, but think about what this fourth equation is going to look like. So we know that it's forming dinitrogen pentoxide and that it doesn't mention any other products, so we should assume that that is the only product in that reaction. So we'll have them on the right side of the equation, and then it is, as that is the only product of the reaction, that must mean that the only two reactants will be nitrogen and oxygen on the product side. So we need to cancel out all these other excess elements in these initial steps until we're only left with nitrogen, oxygen, and dinitrogen pentoxide. So I mentioned it in the other video, but we didn't have to use these not really tricks, but I guess rules or methods in the other Hess's law video because that problem was much simpler. But in this one, we're gonna have to end up using them. So what I'm referring to is a way to help us cancel out these excess elements or compounds. So you can either just call it you can call it like a flip is what I call it. You can either flip the equation or you can multiply through by a coefficient. And something I generally do, I always see if I can flip any equation first. I always try and flip an equation before I try and multiply it or divide it by a coefficient. And then once I flip everything I think I need to, I'll then go through and multiply by coefficients if needed. So here I'll illustrate what I'm talking about. So you know from the previous video, the only way you can cancel a compound or an element is if it appears on, say it appears on the left side of one equation and the right side of another. You can't cancel out compounds if they're on the same side of two equations. So for example, we know that we're only looking for nitrogen, oxygen, and dinitrogen pentoxide on the final equation. So that means that nitric acid, which is appearing in two equations here, must cancel out somehow. However, you see in the second and third equation, nitric acid is a product in both reactions, which means you can't cancel it. But if we flip this second equation here, and I'll write it out later, but if you flip the second equation, we then see that nitric acid is now on the reactant side, and dinitrogen pentoxide and water will switch over to the products. And now that nitric acid on the second equation is on an opposite side of nitric acid in the third equation, that gets us closer to canceling it. Now that we flipped this second equation, though, we now need to find a way to cancel out the water, so we must flip the first one again as well. So now that both of the first and second equations are flipped, those are the only two equations we'll need to flip for this Hess law problem. So now we can move on to seeing if we need to multiply through by any coefficients. So the elements and compounds don't just need to be on opposite sides of equations, they also must match coefficients. because if they were not to match coefficients, there would be some left over in one of the two equations where you canceled. So we must have equal amounts on opposite sides of the reaction. So we can see that we need to divide this first. We can divide this first equation by 2. So I'll just write that out to the side here, and then that will get us one step closer to being able to cancel. And now the next equation we want to multiply, or the next question we want to multiply by a coefficient here is this third equation, and we want to multiply it through by 2. One, it just helps us cancel. It'll help us cancel, but also it's easier because this third equation has fractional coefficients, so it'll be easier. It'll cancel out those fractions and just making it easier to problem to work with as well. So now that we've done all these steps, I'll actually write it out. It'll be a lot easier to visualize for you guys. I also advise when you're doing this problem on paper, it's not always common. You'll figure out like what to flip and what to multiply by like the first time through. Sometimes you might flip an equation that needs to be flipped, but that's okay. Just write it out, and it's kind of trial and error with these problems at times. But if you need to, always just write everything out if you need to, and if you need to, get a new piece of paper or erase it and start over again, that's all right. Just these kind of problems, it's hard to see at first, it's hard to visualize. So the more practice you get writing it out and thinking through the process and this kind of method, the better you'll get at them. So once we do all these, once we flip and multiply, we're gonna get a second set of new equations, and these equations are gonna look like this. So we see this first equation has been flipped and also divided by 2. Second equation has been flipped, and the third equation has been multiplied by 2. Now, don't forget, you see that we have a new set of delta H values. Now, don't worry. These values haven't changed by much. I didn't just pull them out of thin air. All I did was apply the same, method that we did to the actual equation themselves to the delta H values. So for the first one, you see flipped and divided by 2. So all I did for this first delta H value was I changed the sign, which is the flip, and then I divided it by 2, and then the second equation I flipped, which I just changed the sign, and then the third one I multiplied by 2. So that's all you need to do for that as well. Always remember that though, because if you don't do that, your answer will be far off. So now that we have these equations all ready, we can now start to cancel out compounds. So we'll start here by canceling out H2O. So we see H2O is on the left here and on the right here. Now, if we go again, we can now see that hydrogen in this first equation is on the right, and it is on the left in the third equation, so we can cancel those. Now, we can also cancel nitric acid, which on the left here and on the right here. Now, we're left with nitrogen, oxygen, and dinitrogen pentoxide. However, we still need to cancel out this oxygen in the first equation, even though we need it for the final reaction. If we don't cancel out this half oxygen, there'll be excess oxygen in the products. So we cancel this here, and then we just change this coefficient in oxygen for the products to 5/2. And once we do that, we'll get our final equation here underneath, which is N2 plus 5/2 O2 yields N2O5. And then to get a final delta H value, all we need to do is add the 3 previous values, so 285.8, 73.7, and negative 348.2, and you'll get your final delta H value for the formation of N2O5, which is 11.3 kilojoules. All right, guys, I hope this helped. Just make sure to keep practicing these Hess law problems and write everything out if you need to. And with these problems, just the more practice you can get, the better you'll get at the problems. All right, see you guys next time.